What's up, everybody? Welcome back to the channel. So today's video is going to be a little bit different. I was recently reached out to by students competing in the Met2 Design Challenge, and they were wondering if we could talk about their project and talk over some assignments that they've had and just kind of get information on my background and how I might tackle some of their challenges. So we spent about 2 hours together. This video today is a portion of that. Where we kind of work through one particular model. I'm going to be rolling out the rest of the interview throughout the rest of the week and the upcoming days, so definitely stay tuned for that. I hope it brings you some value. If it does, please leave a like, subscribe to the channel so you can get the other segments that we'll be rolling out, and if you have any questions, be sure to leave them in the comments. I'll be looking forward to talking with you guys there. Have a good week. Hello, my name is Josh, and I'm an engineer with Forge Product Development. Forge helps clients start and grow their businesses by providing affordable access to effective engineering resources. Monday through Friday, we offer a free engineering helpline live on our social media platforms, where we help answer questions from people just like you. The clips that follow were taken from one of those sessions. I hope you find it useful and enjoy. All right, so this is something that's round, right? But not very different than our wheel. So we're going to use a slightly different technique, but so it looks like it's already established in the center of the, like just looking at it, it looks like it's already established in the center of these planes. We can confirm it by making an axis with our planes. One good rule of thumb is like trust but verify. So we know that like it looks pretty good. Like it looks good enough, and that somebody's probably adjusted this so that when the STL loads, it's right. But one hard thing with scan data is sometimes the origin isn't properly defined when they export the file, and so you'll bring in a scan and your origin is miles away, right? Like you're not even close, or maybe it is close, and that's why I'm doing this just kind of as an example. Maybe it is close, but it's off by like 50 thousandths in a big model, and you'll never see it until you go to put that part that you designed into something and you're off by that because you just assumed it was in the right spot, right? So what we're going to do is we're going to we made an axis which is super stable because it's based on these planes. And now before we start using these planes, we're going to verify that the center of this imported body is in line with that axis. So we're going to find the front plane. We're going to do the same thing we've been doing for a while.
So you didn't even try and draw it on the surface. You just put a big old circle up there and then start picking points.
Yep. Yep. Exactly. And that's the same thing that we were doing on that first one, right? Or like when I was doing the cutouts. Invalid sketch geometry. Okay. It's make something that's the right shape and then go in and add the relationships, because the relationships will snap everything down. And it really goes like draw your shape, add your relationships, then your dimensions. Because when a lot of the time your relationships are going to do a lot of the heavy lifting for you. So a sketch may only need like 3 dimensions, right? Like if you were going to draw, say you're going to draw a dice, right? The face of a die. You've got a square, and then you've got maybe like five holes or something like that, right? Those holes all have to be in a certain relationship to each other and a certain relationship to the square. So at the end of the day, all you need is like, you only need 1 dimension on the side. Like you can do it really quick, right? You're going to draw a dice, and a die looks something like this. And then say you've got, 3 circles. 1, 2, 3, right? All of this has a relationship to each other. So like this, we know has to be equal to here. These need to be the same size. We know that these are actually going to be a mirror of each other across the middle.
So we could create their feature and then mirror it across, which would be a good way to do it. But you can also do something like this, right? Create a construction geometry. Pick these guys, and there's a symmetry, right? We also know that they need to be on this diagonal. So we'll make this construction geometry. We're gonna fix this because otherwise stuff's gonna start walking off. Right? We know that this has some size to it. Right? And so actually to really get into this, we know that say we want the distance from here to we want the space between the circles and the edge of the dice to be the same, right? You can go in here and you can say like, okay, I've got a point here and I've got this here and I want to dimension the tangency like this, right? Which you can, and then you can dimension the next one and you can even click it and make it equal, or maybe you set up like a variable where they're talking to each other. But what I would probably do is I would just take this, I'd be like, okay, there's a distance here, there's a distance here, and we want them to be the same, right? And now no matter what I make this, the gap between them, the gap between here and here will always be the same. And that's kind of what I was saying with stability. Like it all goes back to stability, right? The way you do something. Geometry, sketch geometry is very stable. I could have dimensioned this, right? It's cheating now to select the line, but I could have dimensioned this. And and said, okay, I want this dimension here. Go in here, I want to equal this. I mean, they're already equal, but if you select it, it would do it, right? Say maybe they weren't equal. Maybe it's like 0.75, right? I want these to be the same. So you can add a dimension, right? And say that they're off, right? We didn't align them originally. You can click on this dimension and it'll make it equal, right? Which is cool. You can also go in here and say, okay, I want this dimension to equal this dimension, right? So now there's a relationship between the two. When you go and update this one, the other one will change, right? But sometimes you'll have things where you have a dimension and you set this equal, but the way that SolidWorks is solving and it's going through its equations. Let me see if I can break this real quick. Trying to think. Yeah, probably not the way I have it set up. But sometimes you'll set it up and say, okay, like this dimension is my base dimension and this is what's driving them. Sometimes in the way that it's solving, it won't reset this second dimension. So you'll change this to like 0.4 and this will stay 0.5 until after you close the sketch. And that's just a opportunity for it to throw an error later on. So you're much better off if you know that you want these equal, instead of putting a dimension on it and controlling it with the dimension, control it with like sketch geometry. Like put the line in there, make the lines equal, and now this relationship will never break. Like it's not going to solve the sketch until these two lines are the same length, right? And so then all you need is what? You need to do a whole dice, you need one side dimension, and then maybe you want to know how big your holes are. Like, that's an entire dice with 2 dimensions.
That's pretty cool. It's yeah, it's interesting that you mentioned that with the dimensions versus when I was making that logo, yeah, it was a learning experience.
So here's an example. Now I know that I misclicked here, but this is what it would look like if it wasn't centered. You'd have this center point, and then you'd have this axis, and you can go and you can use the measure tool, which is always handy. And we can say, okay, well, how far off are we? Right, you're off by 7/10. No, you're off by what? This is a really big part. So you're off by 8/10 or something like that, 9/10. So it's just off by a little bit. But if we fix this here, I bet it'll go to where it's supposed to. Now I have to make sure that I put the other ones in the right spot too. Yeah, it looks pretty dang good. Yeah, somebody's cleaned up these models nice for you.
This one was off of Thingiverse. This was one that we were playing around with.
So in that case, this is probably CAD that was converted to an STL, because that explains why the planes are all perfect, and why it was only off by like 8/10, which is pretty good. So when you get actual scan data like that little bottle one, like that'll be a good one to go to next, because that has all kinds of problems on it.
Yeah, we're going to ask if we might be able to take a look at either the bottle or the block.
Yeah, that's fine. So let me do this one in one feature.
We don't want to take up too much tonight, but we definitely appreciate it. Yeah, I mean, I'm learning thoughts runs here.
Are you good? Good.
It saved me years of my life, but
this whole class will be available later. Yeah, no, you're all good. So we're gonna use a section plane to look inside of the STL. So you can use this here, right? I'm not sure if you guys have seen this before or not. Section plane, right? It doesn't like sectioning STLs because it's a lot to process, but all right, so now we're gonna do this entire burger press in one thing, in one pass. Something like, looks something like this, right? Just like a fillet. Yeah, it's a fillet. We can fill it. We'll do 2 features. No, we'll do it in 1 feature. Just to say we did it in 1 feature. But you guys can see where I'm going, right? Like, you do that.
one shape and revolve it.
Yep, exactly. And like we did with everything, right? We sketched something that was ugly. And now we'll go back through and use points to define where things are. So because we're in the section view, it's giving me this little double box thing, which is basically saying, hey, there's a point here, but we sectioned it. So you have to turn off the section view in order to grab the point.
I saw something like that. I was wondering what it was. I couldn't grab that point.
Yep. It's basically, yeah, it's saying, hey, this is a section view, or it's the edge of a section view. Like I can turn the section view back on. Actually, it's a good way to find where that point is too. So you can see like it's sectioned through here, and it created an artificial point right here because of the section view. But now we can turn off the section view, and there actually is a point right there, and we can use that to make this line coincident too. And actually, we can make this line coincident to it and do the top all at the same time. All right. So another cool thing is the pierce command. So there's no point here, right? We don't know where this wall is technically. But we can do this and use pierce. And basically what it's doing, it's taking that line that went through the plane of our sketch, and it's putting that point on the line at the point where it passes through the plane. So there may, like, sometimes you're lucky and you get a point, and sometimes you don't. We know that this is that point from above. This is another pierce point. And because this is tangent here, and we're going to make a tangent here, we don't actually need to know the radius. Actually, no, we'll need 1 point. We'll need 1 point. No, we don't. Oh, that's why it's creating the tangent based on this here. So that, like, it added that in, right? We didn't want that. And that's one of those things, is knowing, okay, or thinking ahead, like, okay, I have 2 lines coming down to a point. I'm gonna have a radius between them. I don't know what that radius is, and the software shouldn't solve for it. But I know there's something wrong, because when I snapped that line to it, it solved. And it said, okay, I know this radius, but it doesn't actually. So now for this, like, there's no points on this radius, right? And because there's no points along here, we have to add a point in order to use the pierce command. So we just add a point to the radius, and then we'll pick a line that goes through, and we'll pierce it, right? And then we can also measure and check. We can say, okay, what is this? So it's 12 something, looks like it's probably like 0.5 millimeter. That's probably what it was before that was converted to STL. So what else will we have left? We know that this is going to be on our center axis, so this is already defined. And now we just have this big thing here. And actually there's a flat across there, isn't it? So that's pretty easy. We'll just draw a flat. Make it horizontal. Make it vertical. Trim this back. It doesn't look like it's tangent. Maybe it is. So another thing that it added a coincident constraint between the midpoint, or between the center. There you go. Need one more? We'll just assume the tangency's here, but it's probably not. And that's the advantage too of having the 3D mouse, is you can just fly around. So what I would probably do for this is I'd probably do what we did in the wheel example, where we defined a circle using the 3 points and then snap the radius to it. I'd probably do that. But yeah, then you just revolve. Always pick the more stable geometry. Don't pick the line, right? You might replace this line later. This axis is never going to move. There you go. Done. Yep. All right. Yeah, one sketch. And it's just looking at it and seeing, like, okay, like, it's actually symmetric. Even when I open the wheel too, right? It's like, okay, where's your symmetry? Where's your pattern? What can you do? Like that wheel, looking back on it, you could have done the outside rim, the inside hub, and the main plate that all of those holes get cut out of. You could have done that as an axially symmetric sketch too, right? And revolved all of that in one feature and then cut all your holes in. So maybe that would have been a better way to do it. I mean, you're going to get there either way, but